and pH is determined by using glass electrode. So in any way, pH of any aqueous solution depends upon the concentration of H plus ions. pH is negative logarithm of H plus. When glass electrode is immersed in solution whose pH value is to be determined, the potential difference develops across the membrane, and this potential difference is proportional to the concentration of H plus ions. This potential difference is proportional to the concentration of H plus ions. This is the principle involved in the glass electrode. Principle involved in the glass electrode. How we can construct the glass electrode? How? For constructing glass electrode, it consists of electrically conducting glass membrane, which is made up from sodium oxide, calcium oxide, and silica. So glass membrane consists of sodium oxide, calcium oxide, and silica. Glass electrode taken in the form of bulb and then sealed to the bottom of a glass tube, as shown in figure. The bulb contains 0.1 m HCl solution, and internal reference electrodes such as silver chloride electrode or platinum wire is dipped in solution to make electrical contact with the solution. So hence we can represent here, this one is the silver chloride solid, then 0.1 m HCl glass electrode. So this is the reference electrode we are using, silver chloride, and then so this is the 0.1 m HCl hydrogen chloride glass membrane. So glass membrane consists of sodium oxide, calcium oxide, and silica. Sodium oxide, calcium oxide, and silica. The bulb contains 0.1 m HCl solution here. HCl solution. This is the reference electrode, silver chloride. Hence, we are showing the electrode. We are representing the electrode as silver chloride solid, 0.1 m HCl / glass electrode. What is the theory behind here? The glass membrane of glass electrode undergoes an ion exchange reaction with the Na plus ions of the membrane with H plus ions. Here, M minus Na plus H plus membrane. So, glass membrane consists of sodium oxide, calcium oxide, and silica, right? So, reaction is happening here. Then, same as it is balanced, M minus H plus Na plus. This just changed hydrogen and then sodium exchange. The potential difference across the gel layer of glass membrane between the two liquids, and this is the potential difference developed due to the concentration of C1, concentration of acid solution inside the bulb and the concentration of the acid solution into with the glass bulb is dipped. So here first we took the 0.1 m HCl, but this is the reference electrode, this is the bulb, We are dipping here. So what is happening? So ions, H plus ions are exchanging. Glass membrane consists of sodium oxide, calcium oxide and silica. So due to this, potential difference will be observed. That is the potential difference developed across the gel layer of glass membrane between the two liquids. This potential difference developed due to the concentration of acid solution where it is here inside the bulb and the concentration of acid solution into which glass bulb is dipped here. That is, a potential difference will be developed across the gel layer. So here Eg is equal to RT by NF ln C2 by C1. Here C2 is the concentration, both are concentrations. But C1 we know, that is the 0.1 m HCl we took. So Eg, electrode potential is the Eg represents electrode potential of glass electrode. Glass electrode. Here Eg is equal to E0G minus, same as per Nernst equation, 0.0591 log H plus. So entire these things converted into the everything, if we can substitute it, this will be use this one. Okay, log H plus ions. Because this is the C1 is 0.1, then C2 we can, as we know that pH is equal minus logarithm of negative logarithm of H plus. Negative logarithm of H plus. Hence it comes to top. Okay. Hence it converted into the Ez is equal to E0G minus 0.0591 log H plus. So minus log H plus, negative logarithm of H plus is equal to nothing but pH. Hence this equation comes to like this. That is E0G plus 0.0591 pH. Hence here E0G is represented as a glass constant. It is represented as a glass constant. For the measurement of pH of any unknown solution, the glass electrode is immersed in that solution and then it is combined with a reference saturated caramel electrode. So we are taking as a reference electrode as a caramel electrode. So we know the concentration of caramel electrode exactly. Hence, the electrochemical cell is represented as, if we are dipping, we are taking as a reference electrode as a caramel electrode. Silver chloride, 0.1 m HCl, glass, solution of unknown pH / saturated caramel electrode. Saturated caramel electrode. So EMF of the cell at 298 kelvins is given as E cell is equal to E right minus E left. E right minus E left. You have to remember this equation too. Majority of the problems will come through this. E cell is equal to E right minus E left. That is E reference electrode minus E glass electrode. E reference electrode minus E glass electrode. This is the reference electrode. Standard caramel electrode we are taking reference electrode. That is, we are represented in the right hand side. And then left hand side we are representing the glass electrode. This is the glass electrode. Hence, E right minus E left. That is E reference electrode minus electrode potential of reference electrode minus electrode potential of glass electrode. That is equal to E cell. Electrode potential of the cell is equal to electrode potential of reference electrode minus electrode potential of the glass electrode minus 0.0591 pH. 0.0591 pH because we are substituting here. Okay. pH is equal to E reference, electrode potential of reference electrode minus electrode potential of glass electrode minus electrode potential of cell by 0.0591. So pH of the unknown solution we can get, we can measure, we can determine by this equation. pH is equal to E reference minus E glass electrode minus E cell by 0.0591. You has to remember here E cell constant is equal to, E right minus E left. That is the E reference electrode potential of reference electrode minus electrode potential of glass electrode. Finally, pH is equal to electrode potential of reference electrode minus electrode potential of glass electrode minus electrode potential of cell by 0.0591. Every time you have to remember Nernst equation. Next, electromotive force of calomel electrode at standard condition is, that is the reference 0.2422. In the last class, we explained this thing. Standard condition. pH is equal to 0.2422 minus electrode potential of the, glass electrode and then cell by 0.0591. The value of E0 is obtained by measuring with the solution of known pH and EMF of such cell is determined by a potentiometer. We can know the value of glass electrode, pH of glass electrode, then by using known solution of known pH solution, then from that we can get finally cell arrangement. So we can easily determine the pH of unknown solution of cell arrangement is represented. It's the 5, see here. This is the calomel electrode, right? This is the reference electrode. Then this is the glass electrode. Here 0.1 m HCl we are taking, silver chloride electrode. This is, then potentiometer we are connecting both the electrodes with potentiometer of platinum wire. So with this we can easily measure the pH of the any unknown solution. Glass electrode, calomel electrode cell arrangement for pH determination. pH determination. This is very, very important one. What is the advantages of glass electrode? It can be used even in strong oxidizing solutions as well as in alkaline solutions too. This may be oxidizing as well as alkaline solution. The results obtained are quite accurate. The results obtained are quite accurate. It is simple to operate and most convenient. It's not easily poisoned. And then pH is easily determined with few milliliters of solution. It can easily used in the presence of metallic ions too. What is the limitation of glass electrode? The glass electrode is sensitive to zeta ions such as Na plus in addition to H plus. Sodium oxide is there in the glass electrode, particularly at pH greater than 9, which results into the alternation of linear relationship between pH and then EMF, electromotive force of the glass electrode. This is the one limitation of the glass electrode, except that it having lot of advantages too. So hence, while we are explaining the glass electrode, you has to take the reference electrode as a calomel electrode, and then you has to remember the Nernst equation. With that, you can easily explain the glass electrode as a silver chloride electrode. Silver chloride electrode. This is mainly, glass electrode mainly develops across the membrane. Glass electrode is develops depends on the potential difference of the known and then unknown solutions.